summation we can directly take inside matrix. So like sigma ak becomes sigma small ak, and then like zeros you write sigma small bk. 14th, oh sorry, I saw different. Okay, I didn't see. The matrix A satisfies the recurrence relation. A power n must be equals A power n minus 2 plus A square minus I. Then matrix A power 50 is denoted by M. Okay. Hmm. Can we use characteristic polynomial? Maybe we can try. Recurrence relation, we should get A square and identity. Most probably, if we use characteristic polynomial, we should get the answer. Try once, characteristic polynomial. If you are not getting the answer, please do text me in WhatsApp. I'll send you the solution. Anything else? Any other doubts? I just want to know how many of you joined only for 12th here, who are not with Akash in 11th. One. No, like I'm planning for next chapter, that is continuity differentiability. So in that next chapter, limits we will use. So like you guys learned limits in 11th grade. So if you are okay, then directly I'll start with continuity instead of doing limits. There, maybe like if anybody having doubt, most probably I'll teach in weekday classes. If anybody wants, you can ask me. I'll post the link in Teams. You can join that class. Clear? Oh, then I think it's almost time. We'll continue solving problems. Step 2, I think the last problem we solved is some 62 or something. 64 is a good problem. I don't know whether you solved earlier or not. So like here I am teaching you how I tackled this problem. Problem number 64. Please have a look on that problem and then like you and try if you can. Then you can. So like if you see, it is not about the Cramer's rule, or it is not about the system of linear equation. First of all, it is about tackling the greatest integer of sine theta and greatest integer of minus cos theta, right? So like if we studied about greatest integer function and we studied about sine and cos, there we would have learned greatest integer of sine theta can be three values, minus 1, 0. 1 is also possible, right? Same thing for greatest integer of cos theta as well. But if you take cot theta, cot as minus infinity to plus infinity, so you have all integers in that case. Now, like I don't know what to do, what I should assume. Should I assume quadrant wise? Should I take something else? Then, like in this problem, options is really key. Like in options, they have given us a hint. In all four options, they are talking about two main intervals. One is pi by 2 to 2 pi by 3. Second is pi to 7 pi by 6. So like, let's say, maybe let me break this one into two cases. Case 1, I'm taking pi by 2 to 2 pi by 3. Case 2, I will take as pi to 7 pi by 6. Clear? Understood? Right now, I will take these cases and I'll find what is the range of cos theta, sin theta, then the greatest integer value in that range. Same thing for cot theta, substitute in the determinant. Clear? So like since the given system of linear equations is a homogeneous system, we can have either unique solution or infinitely many solution depending upon the value of determinant delta, value of determinant of coefficient matrix. Clear? Right? So like maybe I will do one case here, remaining case you go home and do. Clear? Any doubts? So if anybody else have any better method, I think like you are ahead of me. You solve next problem, please. Right, this is what I have. Case 1. Theta belongs pi by 2 to 2 pi by 3. This is in second quadrant. I can see neither pi by 2 nor 2 pi by 3 is there in the given interval. So it is an open, right? So like next, in this interval, let me write what is the range of sine theta. Sine is a decreasing function. I can say root 3 by 2 will be less than sine theta will be less than 1. Next to this, I can write here greatest integer of sine theta as please must be equals to 0. Any doubts on this? Right? This much only. Now what about cos theta? Now in this interval, if we are thinking about cos theta, cos pi by 2 is 0. Like cos is still decreasing, clear? Cos is a decreasing starting from 0 till pi. At pi only it reaches the minimum. So decreasing function, I can say for cos theta, maybe this might be minus 1 by 2 is less than cos theta is less than 0. They are not asking about cos, they are asking about minus cos. Multiply with minus again, 0 less than minus cos theta less than 1 by 2. So this implies greatest integer of minus cos theta we are going to get is 0. Notice that in this case, the equation number 1. You want AC dear? AC is not on there. Sorry. Okay, like I'll get the AC remote, give me 2 minutes. Right? So like if in this case, the equation 1, if I'm substituting, what is the equation 1? That is greatest integer of sine theta into x plus greatest integer of minus cos theta into y must be equals to 0. Now the second equation, whatever it is, I say that greatest integer of cot theta plus y is equals to 0. Notice that if I write this one in delta, I'll get delta is equals determinant 0, 0, some greatest integer of cot theta value and you have 1. We learned that if one row is equals to 0, delta value must be equals to 0. In this case, we can have infinitely many solutions. Am I clear in this? The second case, do at home. In second case also, same thing. I get the AC. Please pass it. Understood? Any doubts in this? Anybody? Right? So second case you can try at home. After finishing the second case, you can mark the option. Right? Maybe like problem number 66 will be the next problem what I am going to discuss in the class. Because in 66, not only this Cramer's rule, you need something from conditional trigonometric identities. Please have a quick look on the problem so that you will understand. I am scrolling up. I hope everybody copied the solution. So can we start? So in 66, they have given this condition alpha plus beta plus gamma is 2 pi, and they have given a system of homogeneous equation, right? So can somebody calculate determinant for me and tell directly, like you can expand directly? I don't think we can use we can use, maybe we can directly do it. We are getting the answer, not difficult one. Somebody please do for me. Tell me what is the value of delta. Where is AC remote here? I'll collect it, keep it there. Don't take that one to home, please. Huh? So anybody, what is 1 minus? Okay, one moment. 1 minus cos square alpha. Hmm? Day before yesterday, I thought same problem. So check whether we are getting same or not. So like, I'm not wasting much time in calculating delta. Just expand it. Take the determinant of a coefficient matrix, expand either any row or a column. Using that, you should get this one. Let me know if there is any correction in this. This one only we are getting now. So like now, the problem of determinants, they are connecting with trigonometry conditional identities. Let me rearrange this one, and then like this must be, okay, let us write 1 plus 2 times of cos alpha, cos beta, cos gamma. This is in one bracket, and the second bracket minus 1 into cos square alpha plus cos square beta plus cos square gamma. If anybody remember this, I can say like this bracket I can consider and I can prove it will be exactly equals to the first bracket. Both will get cancelled. Delta value is 0. So like, don't worry, that one we will discuss here, right? So how to prove that? For that, let us consider cos square alpha plus cos square beta plus cos square gamma. So like after considering, you can take any two, either cos square alpha, cos square beta, any two. Use the formula cos square theta is 1 plus cos 2 theta by 2. So this becomes 1 plus cos 2 alpha, and then again 1 plus cos 2 beta divided by 2 plus cos square gamma. Let it be in this way. Clear? So like now 1 plus 1 is 2, divided by 2 must be equals to 1 here. So we can say 1 plus 1 by 2 into cos 2 alpha plus cos 2 beta plus cos square gamma. So we can see cos C plus cos D formula we can apply. So after applying that, we will get 1 plus 1 by 2 into 2 times of. Notice that we get cos of alpha plus beta into cos of alpha minus beta plus cos square gamma. So they have given in the problem alpha plus beta plus gamma is 2 pi. From there, alpha plus beta will be 2 pi minus gamma. So using that, I can say this is 1 plus cos 2 pi minus gamma into cos alpha minus beta plus cos square of gamma. Cos 2 pi minus theta is cos theta, taking cos gamma common. So this is 1 plus cos gamma into, the remaining is cos alpha minus beta plus cos gamma. So again same thing. As we showed earlier, cos alpha plus beta is same as cos gamma. So in this cos gamma, I'll write cos alpha plus beta. So this is 1 plus cos gamma into cos alpha minus beta plus cos alpha plus beta. Now expanding this, we'll get 1 plus 2 times of cos alpha, cos beta, and cos gamma. So like that's what I said. Now maybe you can change sides for this one entirely. You will get that is determinant delta. Delta will be equals to 0. Any doubt in this, anybody? Now this implies I can say delta is 0. Delta is 0 means system has infinitely many solutions. Again, like if you are listening to the class or solving the problems, you would have noticed they are not only giving the Cramer's rule, we are connecting the Cramer's rule to some other concept. In one concept, if you see, they connected to planes, distance of a point and a plane. They connected to probability in one problem and they connected to trigonometry here. Earlier in one problem, they connected to the properties of greatest integer function. Clear? So if we are, let's say, not good in any of those concepts, we are not going to solve this one, right? So in some cases, they will try to make the calculation lengthier. So if you can use shortcut and get the answer as quickly as you can. Any doubts? Anybody? Okay. There is some background noise I can hear. If any doubts is there, maybe I can help you if you ask. No, no, no. Like this is the determinant. This much you understood. I have considered this one, right? And I have proved this one entirely. Like you call this is maybe let me call this one as capital P. This is capital Q. What we did, we considered the Q and we did the calculation and we showed here P is equals to Q. If P is equals to Q, then P minus Q or Q minus P will be zero only. Anything else? Any other doubts? Can I scroll this one up? Done. Scrolling up. So what Tarun is sleeping there in last bench? Tell me truth. Half sleeping. Then do one asana. Stand up and write. Sleep will go. Sitting next to AC, nicely AC is there. 18-degree fan is there. Huh? Perfect place to sleep for Madurai temperature. Appa, this one. Again, there is some background noise that I didn't like. Done.
Sir,
Yes,
sir,
dear. Yes, dear.
how
I
how will you say cos gamma is cos alpha plus beta, sir?
I can write here cos gamma will be equals to cos 2 pi minus alpha plus gamma is 2 pi.
Okay, sir. Okay, sir.
Hmm. Anything else? Anybody? No doubts, right? So if you have any doubts from Cramer's rule problems, you can ask. What I believe is I solved enough problems in Cramer's rule. If you feel any model I will teach, you can ask me. We will try it. Any doubts? Then there is like another problem where we should use the properties of determinants. Uh, this is problem 42 of page 87. So like that much only from my side in Cramer's rule. If any doubts you have, particularly you ask me, or else like I'm done in Cramer's rule. Please go problem 42 of page number 87. So like how many of you solved this problem? How did you do that one, dear? P inverse A P you calculated 42 problem. P inverse A and P you calculated, then you did. You did. I think you would have used some other method. Some backside you didn't do. If you are using P inverse A into P, maybe I have a little better one. If you have that better one, I don't have anything else, right? So like what I can do here is maybe I can use the properties of matrices, inverse matrix and determinants, right? So given 42nd problem, so they said a matrix A is given, matrix P is given. I'm not going to find P inverse. I'm not going to multiply P inverse A into P. See, like multiplying 3 by 3 matrix twice itself is difficult task. 3 times if you do, somewhere let's say one small mistake happen, we are gone. That is P minus. No. Matrix multiplication is non-commutative, no, in general. You cannot shuffle like that in matrices. That is the rule, right? So in 42, what I should do here is I should find a determinant of this matrix. Let's say it is matrix M, given that P inverse A into P minus 2 into identity matrix, right? So maybe what I thought here is the identity matrix over here. I can write as P into P inverse, or I can also write as P inverse into P. As they have given, first I'll write P inverse, then I'll write P. If I do that, P inverse A into P minus 2 times of P inverse P here. So like what I can do here, like left side, everything P inverse is there, that I am taking first common. This is P inverse into A into P minus 2 times of P. Now right side there is P. See, like when I am taking P common, don't just write 2 there. I should write 2 into identity matrix. So this is P inverse A minus 2 into identity matrix into matrix P here. Now let's say we are taking determinant on both sides. This is determinant of P inverse into A minus 2i into P here. So in determinants, I learned that this will be equals to determinant of P inverse, determinant of A minus 2i, determinant of P over here. So P inverse, P determinant will be cancelled. This must be equals determinant of A minus 2i. A we have, 2i we can calculate. Then determinant is not difficult thing is what I believe. Like don't try to overuse the characteristic polynomial or whatever it is. You can find the roots. You can like again for third degree you should find the cubic polynomial. We don't have a proper method to solve cubic polynomial unless until we guess some root. Clear? So here it is simple to find matrix A minus 2i, then take determinant. Similar kind of problem you have in 57. Please do check once. I think the omega must be -1 plus I root 3 by 2 in 57, right? 57. Again, same kind of concept we can use there. I hope I am clear. This much only I want to teach. From here, what I believe is you people can calculate. Any doubt? Anybody? Any doubt? Anybody? No doubt, right? Shiva Kumar, you changed batch, huh? We are finding you in that batch. Attendance, I think 4 or 5 days it is continuously absent. I don't know. I think they didn't change name. One more student. Where is Ajay? Ajay Khanna. His name is also still in that batch. Why, re? He don't have idea. They didn't change in the batch. Yeah. So any doubts in this calculation? Anybody? Any doubts? Then that's all. Maybe one problem or two problems in advance. Some easy ones. Beyond even. Okay. So, done in this, right? So please go page 113. Problem number 22. Page 113. Problem number 22. Right? That one and one more problem I'll teach before moving into the matrices. Please have a look on the problem once. 22. Anybody solved this one? Sorry. Anybody solved this problem? Here we can use characteristic polynomial or eigenroots and eigenvalues concept, right? How to use this? Like, first of all, let us read what is given. Given matrix is a 2 by 2 matrix, second order, right? Given details is trace of the matrix is 3 here. And what else they have given? Trace of a cube is also given. Trace of a cube is -18, right? Then what we need to find? We need to find determinant. There might be different methods. So this one I felt easier. So I'm explaining here, right? Okay. Let us write in terms of eigenvalues. For the given matrix, lambda 1 plus lambda 2 is equals to 3. For A, if it is lambda 1 and lambda 2, for A cube, it must be lambda 1 whole cube plus lambda 2 whole cube is equals -18. We need to calculate product between the eigenvalues, that is determinant of the matrix. Clear? Everybody understood this much? Any doubts in this? Anybody? Right? So next, what I do here, I'll use little bit algebra here, right? Let us do cubing for this equation. If I do cubing here, I'll get lambda 1 plus lambda 2 whole cube is equals 27. Now I can say this is lambda 1 whole cube plus lambda 2 whole cube plus 3 times of lambda 1 into lambda 2 into lambda 1 plus lambda 2. Any mistake I did? Right, equals 27. Now let us plug all those values. We get -18 plus 3 times of lambda 1 into lambda 2, and then it will be again into 3 is equals 27. So 9 times of lambda 1 into lambda 2 is equals 27 plus 18, 45. So now we can say lambda 1 into lambda 2 is equals to 5. Clear? Any doubts in this? Anybody? This is what I have. You can copy this one. Next, I think, as far as I remember, I told the conditions won't work for parallel planes, but I didn't give you any example or anything like that. For that, problem number 20 we can solve. Clear? Did I give any example for parallel planes? No. Then we will do 20th one. See, like parallel planes is similar to parallel lines. In parallel lines, what happens? X, Y coefficients must be proportional. Constant is different. Correct? In planes also, X, Y, Z coefficients must be proportional. The remaining constants is there, no? That is not proportional. That is parallel planes. For example, we can say the ground floor equation is ground floor like this one I'm talking floor. X plus y plus z equals 0 because it is ground. X plus y plus z is equals to 1 first floor. X plus y plus z is equals to 2 second floor. Clear? So three planes are parallel. Even though you find the delta x, delta y, delta z, all you will get 0, but they don't have any line of intersection in between. You can use shortcut as well. In shortcut also you will get some unique value of p will be existing, but the planes are not intersecting. Any doubts? Done. So problem number 20, please. Next. There is some background noise which I didn't like. If you are solving why that sound is coming. I just want to know how many of you are solving by yourself, not listening to my class. Raise your hand, please. I just want to see. 7 o'clock, show me your notes, how much you solved in this class. If anything less than 10, I want to talk to your parents. Anybody else who is not listening to my class and solving? I just want to know so that I will check your notebook after 1 hour. Clear? 1 hour, 10 problems, okay? Or 20 can we make? Huh? 15, okay. Let's do deal 15. 20th problem. Let us read what is given. For a real number alpha, if the system of equations has infinitely many solutions, then 1 plus alpha square. So the most common doubt student will ask here is that like here I did delta equals to 0. Then I got the value of determinant, the value of alpha as two values. Which one I should use? I tried finding delta x, delta y, delta z. All of them are 0 in both the cases. Clear? So that I'll explain. You just tell me what is the value of alpha. That calculation you are all equipped enough to do. Equate delta to 0 and tell me what is alpha. What are all the values of alpha we are getting? I believe there is no printing mistake in this problem. I did check earlier. Everything is correct. Just tell me what is alpha value here. Anybody with shortcut here? How you calculate it? No. Shortcut also we can use. Like we did this one 0, so alpha equals plus minus 1. Right? So So I don't want much here. This will do. Like if case 1, if alpha is equals to 1, notice what is happening to the equations. I am writing the equation. Equation 1 becomes x plus y plus z is equals to 1. Correct? Equation, not as not assuming. You only said no plus minus 1. In that one I am taking. Right? I just want to write this. Second equation becomes again x plus y plus z is equals to minus 1. The last equation is x plus y plus z is equals to 1. This is the case of parallel planes. You will get delta equals delta x equals delta y equals delta z equals 0. Y in delta anyway 0, let it be. Delta x, if you are replacing column 1 with 1 minus 1 and plus 1. Column 2 and column 3 are identical, you will get 0. Delta y also same thing. Delta z also same thing. Even though all are equal, the planes are parallel. That's what you should notice. Actually, this is not 3 planes, only 2 planes. This and this are same equation. Clear? So like planes are parallel. If planes are parallel, no solution. You can check for second case. That means this cannot be the value of alpha. Understood? Right? So case 2 you should take if alpha is equals minus 1. In this you will get all deltas will be 0, and this is the situation of infinitely many solution. Right? Yes, ma'am. 0. Infinitely many solution. Now what we should calculate? We should calculate 1 plus alpha square. I think that must be equals to 1. Any doubts? Any doubts? Any doubts? If there is some doubt, you can ask me. If no doubt, we'll go to the next problem.
Sir,
Case 2 straight line only there. Case 2 3 planes, not parallel. It, no, not coinciding. I told no. You take your book. Half you write keep like this, remaining half you keep like this. This is the infinitely many solution situation. So like in between hanging some pages, no, that you can take as plane number 1. This side you take plane 2, plane 3. So all three are intersecting here on a line. That's only infinitely many solution. Am I clear? Anything else? Online students, some doubt here?
sir, can you explain the case 1, sir?
Case 1, for alpha equals to 1, you can see no planes are parallel here.
Okay, sir.
That's why only solution won't be there. If planes are parallel, there is no point of intersection. If no
Okay.
point of intersection, then how we have infinitely many solutions? So anything else? Any other doubts?
Sir,
Yes, please.
in case one del x, del y, del z, one of them will not be zero, no, sir.
No, 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 no. See, like, notice here in del x, C2 and C3 are identical because y, z, z, z. Clear? See, like in del y, you will get C1 and C3 are identical because 1, 1, 1, again 1, 1, 1. In del z, you will get C1 and C2 as identical. Again, one moment. Please be quiet. You can notice that one clearly in this. Do you need further explanation here?
So no, sir.
Thank you. Then what else? Anything you solved? Any doubts is there? What I think is like except 21 and 16, I did solve the remaining. Oh, no worries. Then let us go to the matrices problems. Right? So I tried to cover. Scroll. Okay. I tried to cover some important models from determinants. I did from my side. Your side, you also solve few. Any doubts is there? You can ask me. So in matrices, I hope that given system has infinitely many solutions, they said. So I equated the delta to 0. Then I got alpha value as either +1 or -1. Anything else you need? Delta equals 0 I did. Only two roots I have. One is +1, another is -1. Right? Anything else? So then this is matrices. In matrices, I think we solved few problems where pattern finding and then doing. Did we solve any problem or we didn't do anything at all? We did few, right? Okay then. The pattern problems then we are not doing. Then 23rd problem, if you see, problem 23. I think I didn't taught this one here. As far as I remember, I taught in weekday. In 23, right? That we will see. 23 of page number 30, I am speaking. So please read the problem once for you. 30, problem 23. Mhm. There is some background noise that is constantly disturbing me. I don't like that one. If I find somebody, maybe I'll ask you to go out. Politely, I'm saying more polite way I couldn't find. So okay, the given details, if we see, if P is a square matrix such that P square is identity minus P, alpha, beta, gamma, delta are natural numbers. They have given that P to the power alpha plus P to the power beta is equals gamma into identity matrix minus 29 into PV. One more is given, that is P to the power alpha minus P to the power beta is equals delta into I minus 13 into P. Right, this two is given in the problem, and we should calculate alpha plus beta plus gamma minus delta must be equals to. So other than this one, I don't have anything else. Somebody trying to join, but by the time I admit, they are leaving. Not sure. Okay. Right. This detail is given and some equation in terms of P for alpha and P for beta. What I am thinking is maybe first instant is we can add or we can subtract to get P for alpha and P for beta. So we can say P to the power alpha must be equals to gamma plus delta divided by 2 into identity matrix. I think I am getting minus 21 into P. What I did, I added, I got 2 times of P power alpha. I divided by 2 on both sides. 29 plus 13 is 42, right? 30 up. This is what I have. Clear? I added and I simplified. This is not difficult one. So like in the same way, if we subtract it, we get P to the power beta must be equals SW01. Gamma minus delta divided by 2 into identity uh, minus 16, so minus 8 into P. Clear? So this is what we did. Now like what I should do, I am using this relation. There is no way P cube I'll find, P power 4 I'll find. Maybe if somewhere I'm getting minus 21P or minus 8P, I'll compare with that. Clear? So now P square is given, P cube, maybe let us write P square is I minus P, multiply with P on both sides. P cube is P minus P square, substitute P in this. So, sorry, P square, P cube is P minus identity plus P we have. So, P cube is 2P minus identity. This is what I have. Maybe P power 4, 2 times of P square minus identity. So how much is this? You will get 2 times of identity minus P minus identity. So this is 2P. No, sorry. I minus 2P. P power 4 we have.
Sir, in the two steps above, it will be 2p square minus p, sir, not identity.
Oh,
In p power 4 equal to 2p square minus p.
okay, 2P square minus P. Okay, then it must be P here. Then I think it is 2 times of identity minus 3P. Thank you for correcting the mistake. So like maybe what I have noticed in this short thing is in P power 4 and in P square, it is some minus into the matrix P I'm having. In P cube, if I see what I have, I think like in P cube, it is not that plus I have. So some educated guess I'm trying, alpha and beta must be even. Clear? Understood? Right? Maybe P power 6 I can try or P power 8 I can try. I'm trying first of all P power 8. So if I do P power 8 here, P power 8 is P power 4 into P power 4. So this is 2I minus 3P whole square. So this is 4I plus 9P square minus 12P. So this is 4I plus 9I minus 9P minus 12P. So this is how much? 4 plus 9 is 13 into I minus 21 into P. This is P to the power 8. Any doubt in this? Now, alpha must be equals to 8, right? So one more thing I can say, gamma plus delta is 26. Right? So now P power 8 I found, I directly went to 21, but I need minus 8 for beta. So P power 6. Clear? So P power 6 if we do, we get P power 6 is equals P cube minus, in multiplication, P cube again. Yes, please. So this is 2P minus I whole square. So we have 4P square plus I minus 4P. So 4P square na, this is 4I minus 4P plus I minus 4P. So we have 5 times of identity minus 8P. So on comparison, we get beta is equals to 6, gamma minus delta is 10. I think we should need alpha plus beta plus gamma minus delta. So 8 plus 6 is 14, 14 plus 10 is 24. Option 4. Any doubts in this? Anybody? Anybody writing this part of the solution? Can I scroll up? Right, please. Scroll up. Abhinav, given details I moved up alpha beta also. What is P for 4 minus P for yeah, 27 is characteristic. You can find the characteristic polynomial. You will get like lambda square, sum of the diagonal elements minus 1. It's, from there again same procedure. Get a equation, from there try to get the equation. So how many made it here? Around this, at least 7. I think around 30 minutes is over. Huh? Step 1 problems and all I don't even know. You are doing step 1, I will do it. All done. I think the problems next one. 24, we have discussed earlier, right? Say yes, no, please. So if we solved earlier, then 27th one, similar kind of problem. Maybe like in this problem, we can use the characteristic polynomial and carry Hamilton theorem. I'm scrolling up completely. Anybody writing this? Which part? Huh? Oh, okay, please write. Oh, done completely. So 27. So in problem 27, given is a matrix P is there, right? So now P is equals to 2 minus 1, 5 minus 3. N is a natural number. P power n is equals to 5 into identity minus 8 times of P. So like here, sum of two consecutive powers is there, right? So what we do, I can also do in different way, like I can get P power n direct. How can I get like substitute P here, I'll get P power n here. So trial and error I can do. Maybe P square, P cube, there might be a pattern, I'm not sure, I didn't do that way. Using that you can get the value of n. Maybe the option verification, oh sorry, unfortunately no option. Then what we should do, I'm using the characteristic polynomial. Second order, so it will be lambda square. minus 1 into trace of the matrix into lambda plus determinant of a matrix is equals to 0. So this is lambda square. Trace seems minus 1 minus of minus plus lambda. Determinant seems minus 6 plus 5. Right. So minus 6 plus 5 seems minus 1 is equals to 0. This is characteristic polynomial. Now I can say p square plus p minus identity matrix is 0. From here, p square must be equals to identity minus p. I think like same problem only. Uh, I think you can compare, I guess. Earlier we did no. From here, p power 6. So from the previous problem, n must be equals to 6. Clear? Any doubts? Hmm. Which one? I think there also are given lambda cube minus 1 into trace of a matrix into lambda square plus sum of all cofactors of principal diagonal elements into lambda minus 1 into determinant of matrix must be equals to. Right? From the above problem, n must be equals to 6. Then 29 problem I'm doing next. 29 problem is first asked in JEE Advanced. You can find this problem in determinants chapter. Options is like more than one correct problem. We can try that one after this. Right. So let us read the details given in the problem 29 once. Uh, I think Sri Vishnuvardhana, you are Sri Vishnu. And then Shaktivel. You understood? I am getting confused. You and that guy. For my eyes, you two are brother. I am very lazy. I am not writing matrix P here. Alpha belongs to real. Q is Qij. One information is P into Q is equals to Ki3. Given that K is a non-zero real number. Hmm. Then okay, Q23 is given. Minus K by 8. Determinant of Q is also given. That is K square by 2. Now we should calculate the value of alpha square plus K square. So let us start. There might be different ways to do this problem. So like I am going to use this equation. Let us take determinant on both sides. P into Q is equals to Ki3. If we take determinant, this is determinant of P into determinant of Q is equals. Scalar is there inside the determinant. Taking out, I should write K cube into determinant of I must be 1. If you want, normally this matrix is K 0 0 0 K 0 and then 2 zeros and 1 K. Determinant you will get is K cube anyway, right? Now Q determinant is given. Determinant of P into K square by 2 is equals to K cube. Determinant of P is equals to 2K. So if I can calculate determinant of P, I have a relation connecting alpha and K. Correct? So how much is determinant of P over here? So like determinant of P I want to calculate. So somebody please, how much we have? Maybe using column 3. Fourteen alpha. Just a moment. Twelve alpha plus 20. Equating with 2k, we will get k is equals to 6 alpha plus 10. I hope this one is clear to everybody. Any doubts in this? Anybody? No doubts, right? See, like in the problem, there is a line mentioning that k is a non-zero real number. So, using that, I can say determinant of p is not equals to 0. That means matrix P is a non-singular matrix. Inverse of P we can find. For that, P into Q is equals to K into I3. Left multiply with P inverse on both sides. P inverse into P into matrix Q is equals to K into P inverse. Now this becomes Q is equals to K into P inverse formula is 1 by determinant of P into adjoint of P. So determinant of P is 2K. K in numerator and denominator got cancelled. This is 1 by 2 into adjoint of P. Any doubts in this? Anybody? See, like, listen to me carefully. Few students asked me doubts earlier. In this step only, we have given second row, third column element of Q here. So, like, I can write here Q of 2, 3 must be equals to 1 by 2. I'm taking a pause. Adjoint of a matrix you will get after taking transpose of cofactor. If I want second row, third column element, that must be the cofactor of third row, second column element. Understanding? So, like, this is cofactor of P32. If you are taking cofactor of P32 after doing transpose, it will go to the 2, 3 position. Am I clear? Anybody need more explanation here? Ma'am wants to speak with you.
Online students, please open My Akash app. In that, you have rate your experience. So click on that and rate your experience. Sir will give you 5 minutes, ma. complete பண்ணிட்டீங்களா? Completed everyone. Over. Over. Speed level.
So then we'll start from where we left, right? So like, how many of you didn't understand this step? See, like, listen carefully. The matrix QS 1 by 2 times of adjoint of P, right? So maybe if I write in the space, right? So we have, this is cofactor matrix of P. I can say P11, P12, P13, P21, P22, P23, P31, P32, and P33. So like, in order to get the adjoint, I should do a transpose. Once I do the transpose, what happens here? If you see carefully, these two elements must be interchanged. Correct? So now, what they have given in the problem, they have given Q23. Q23 na, this element went there, right? So that's why only I have taken it one cofactor of P32. Need more explanation, anybody? Understood? Right now, let us go to the matrix P. Sorry, I didn't wrote here. In matrix P, if you see, third row, second column element, I think it must be minus 5. How much is cofactor of minus 5? This will be equals to 1 by 2 into, right? If I do minus 1, I should multiply here because the sign minus 1 into 3 plus 2, that is minus 1. And then 3 alpha plus 4. So now we can substitute Q23, that one is minus K by 8. So K got cancelled on both sides. Minus 1 got cancelled. K is equals to 4 3s are 12 alpha plus 60. So using these two equations, we get alpha equals minus 1, K equals 4. So alpha square plus K square is equals 70. Any doubts in the slide? If no doubts, anybody writing this slide, please write fast. Again, some background noise continuously irritating. I have multiplied seeing everything I cannot write. I can speak fast, but I cannot write. That maybe I should improve. You write multiplication with P or something. After that, if I multiply with P must into Q is equal P into P. P inverse is what? The determinant of P into unknown. Determinant of C is to K got cancelled. So 1 by 2 into unknown. Anything else? And here, practice. And I see here currently how many you solved. I said earlier only it's 2 I feel if you solve almost all. Okay, can I see it's in or pending? So we step 2 and step 3. Huh? No, you don't have habit of marking the answer or making. How we will differentiate which one you solved, which one you did. Let me give you some problems. Okay, 5 minutes is there. You try. This one you want. This one is there. If you want, I can give you. I cannot put this one on the video. Like, for important matrix. Important matrix was only principal diagonal. Alpha plus gamma must be 0. Take the you can also take you find the equation and raise equation. Sum of all elements here. That one only I can explain what then so like anybody writing this part? No, right? So like after 29, let us do problem 33. 33, maybe 35, 36 if time allows, 38 and so on we will do. Scrolling up. Please stay quiet. Problem 33, matrix A is given, matrix B is equals to A minus identity. They have given omega is equals, that is cube root of unity, complex cube root, minus 1 by 2 plus I into root 3 by 2. It is cube root of unity. Then the number of elements in the set, okay, n is equals to, okay, they have given a set. Inside the set we have 1 less than or equals, n less than or equals 100, and n belongs to natural numbers, such that a to the power n plus omega into b to the power n must be equals to a plus b. Right? So I need some help. Can somebody calculate a square and tell me what we are getting when we do a square? A, who is speaking that? A. So like, I think he is correct. A square will be equals to A. If A square is equals to A, what is that matrix called? Idempotent matrix. Right? They have given B is equals to identity minus, A minus identity, correct? B is equals A minus identity. Now let us find a B square, right? So B square will be equals to A square minus 2A plus identity. So A square will be equals to what? A minus 2A plus identity. So we have here minus identity plus, minus A plus identity. So minus 1 into A minus identity. So I have here B square is equals to minus B. Any doubts till here? If B square is minus B, oh, one moment. I think I cannot draw from one page to second. Right? Any doubts till here? Anybody? So B square is minus B. So using this, like maybe B cube we can write is equals minus 1 into B square. As we have know B square is minus B, we have B cube is equals to B. B power 4 will be equals to B square. That means B power 4 is minus B. So like I have noticed a pattern now. B to the power even number, if I am doing like in this case minus B I have, in this case also minus B I have. B to the power odd number if I am having, that will be same B. You can find B power 5 to justify this argument. Clear? Any doubts? Right? So maybe for idempotent, I don't know whether you remember or not, whether you noted or not. I have given there a to the power n must be equals to a for all n belongs to natural number. A square, a cube, a power n all must be equals to a. That is the property of idempotent matrix. Using that property, I can say a to the power n plus omega to the power n into b to the power n will be equals to a plus b. Substituting a power n as a plus omega to the power n into b power n is equals a plus b. So a will get cancelled. Now we have omega to the power n will be into b power n must be equals to b. Now like two things I can say. First of all, this n should be a multiple of 3. Then only omega will be vanishing, or else it is a complex equals to real never happens. Am I clear? omega must be a multiple of 3. That is like first observation we can derive from this. Second one, as we wrote here, the power of b must be odd, then only we will get b there, or else we don't get b there. Clear? So to get omega power n into b power n is equals to b, I can say here n must be one moment odd multiple of 3. Now your doubts. If even multiple of 3 is there, you will get minus b. No, minus b is not equals to b. Clear? It must be odd multiple of 3. So from the given interval, I can say n can be 3, 9, 15, and so on, going till 99. So I think you are all equipped enough to tell how many n values are there in the set. Any doubts? Anybody? Any doubts? You can write. See, if you already solved these problems, there is no point of listening again. I am not giving chocolates or biscuits to listen this. You can solve whatever you like from maths. But what I request is don't disturb class. Ora? Huh? Tell me what is the answer there. Okay, can you justify why it is? Huh? Coefficient matrix? Unmatrix. How you can tell it is? How you can tell it is? Some baseless arguments. I'm not going to justify. That is one baseless nonsense argument. For that I should do. I'm giving you try again. Any doubts? No doubts. You can go for break. Please be on time. 7:10. Again maths class. Chemistry sir is not here. We'll continue. Am I clear? Any other doubts in this? Ah. Where if see dear from this equation I should say first of all omega should not be there. You take 1 or you take 2, you will get a complex in multiplication, no? That won't be equals to 1. This omega power n must be equals to 1. When it happens? When n is a multiple of 3. Clear? So it can be even, odd, negative, positive, anything. Okay, clear? So like now, from the given set, what I can say, n must be a multiple of 3. That is conclusion 1. Second one is like b to the power, omega gone. Now, b to the power n always not equals to b. B to the power n will be equals to b only if n is odd. If n is even, I have b to the power n as minus b. Clear? Understood? Any other doubts? So how many matrices are there like this? How many n values are there like this? Sorry. Perfect. You can go for break. Don't worry about attendance. I won't mind about it. Some random, anybody didn't punch the ID card or something? No ID card, huh? Sold in second hand, huh? Then where it is? Super.
Sir, when you will start next chapter, sir?
Next chapter, I think tomorrow, dear. If class is there tomorrow, I'll start.
Okay, sir.
Hmm.
Sir, why we multiply only 3, sir?
Where?
Sir, in omega.
It is property, dear. Omega cube is 1.
Okay, sir. Okay, sir. The complex number.
That only, that one only.
Okay, sir.
Online guys, we'll meet in next meeting. Please log out and log into the next meeting. See, in Tamil they'll tell no, run away from me. Don't show your face again, or else I am going to beat you badly. See, like in matrices, you would have learned very clearly. Product between two matrices is equals to null matrix. Does not mean one of them must be null. Both can be non-null. Correct? So then that is one baseless nonsense argument what you have derived after seeing the answer. That I am not going to encourage. Huh? So don't waste time. If you are not solving it before me, you will get some punishment. No, I will teach to everybody. Right? So like you are not listening to my class, no? Then like either you would have solved these problems earlier or you are smarter than me. Maybe the second one, let us say. Right? No, I have no problem in that. Most of you are smart, really smarter than me. But like tell me no how you will do. See, that you only scratch your head or go home and die. I don't want. Tell me the answer. Proper argument. I think you talk with somebody in staff room. Here you want to put. I think you. I don't know. I'm not responsible if it is getting lost. You can keep that.
Yes. What about you people, sir? Pratish? Right, sir. So give the survey without fail, and those who have been forget the password or Sujan or Shivakumar. வீட்ல போய் பண்ணிடு மறந்துடாது. Right. And those online students, those who have not given, kindly take this time. So I'll give you 5 minutes of time. So complete it, and then I'll say sir to start the class. Right.
We are in between this problem, so this much we wrote. So I wrote all the details which is given in the problem. It is mentioned in the problem A and B are third order matrices, square matrices. A is symmetric, B is skew symmetric, and they have given a system of what equations are these? What equations are these? linear homogeneous. Clear? So something like this we have mx equals to 0. Now if we notice in the options, option 1 is saying exactly 2 solutions, infinitely many solution, no solution and unique solution. If you have learned how to solve system of homogeneous linear equation, there you would have noticed the two things. All planes are passing through origin. That means at least one solution will be there. Clear? Or infinitely many. No solution and exactly two solutions are not possible, discarding them here. Two are there. Now how to get one of them must be the answer. Right? Again, if determinant of matrix M is 0, then it is infinitely many. If determinant of matrix M is non-zero, then unique solution. But like I have no clue. No matrix A is given, no matrix B is given. If there is A and B, then I would have tried A square into B square and then B square into A square. I would have substituted or I would have got determinant. But that is not there. Then what I should do? Right? What I can or what I should try in this is I have solved the problems. They will give a matrix like this. They would have asked in option symmetric and skew symmetric nature of the matrix. So I am going to use the symmetric and skew symmetric nature of the matrix M. To tell whether it is symmetric or skew symmetric, I need to calculate M transpose. M transpose is A square B square minus B square A square whole transpose. Now this becomes A square B square whole transpose minus B square A square whole transpose. Now like applying law of reversal, this is B square transpose into A square transpose minus A square transpose into B square transpose. Interchanging transpose and square, this is B transpose whole square, A transpose whole square minus A transpose whole square into B transpose whole square. Now, whatever it is, A transpose is A, B transpose is minus B. Plus B or minus B doesn't matter. The powers are even. We can write this will be B square A square minus A square B square. Notice that after taking minus 1 common, we can write M transpose is minus 1 into A square B square minus B square A square. Now I can say here M transpose is equals to minus 1. Minus 1 into M. So what is this matrix called? Skew symmetric matrix, right? If it is skew symmetric of order 3, what must be the determinant of M? If it is skew symmetric of order 3, what must be the value of determinant? 0. Correct? Like in determinants, if I remember correctly, I made you write. In book, I think it is not there. In notebook, you should check. Determinant of a odd order skew symmetric matrix must be 0. Right? So like determinant of M is equals to 0. This implies what solution or system of equations has infinitely many solution. Understood this? Again, like what inspired me to check the transpose or like what inspired me to do the symmetric and skew symmetric, that is in A and B. Other than symmetric and skew symmetric nature, I don't have any details. Clear? That's what inspired me to do this. Any doubt in this, anybody? It is not always null matrix. Clear? If any doubts, I'm okay explaining again. Please ask. If no doubts, next problem, let me tell you. No, x square is not defined. No, x into x. It is 3 cross 1. That is again 3 cross 1. 1 and 3 are not equal. M square into x can be given. M can be any matrix. Not any matrix. In this case, this is the matrix. Any doubt? Anybody? Understood? Please write here. Y determinant is 0. Clear? So why the determinant is 0 here? U symmetric matrix of odd order. That must be there here. Let's say I'm reading this notebook day after tomorrow. I won't be knowing, no clue how it is 0. I didn't remember that property. Clear? Please make that one as a habit. Why we are writing that one? So like infinitely many solution. So moving to the next problem. What I can sense in the next problem is I going to solve 49th one. If anybody wants any hints in between, I'm okay. Maybe if I remember, I can give you some hints. 49 will be my next problem. In between anything, if you want, please do let me know. I might give you small hint or something. You got the answer or not? I don't want explanation. 49. No, that in a hint I don't want. Answer you got or not? No. Without answer you are giving it. Oh, you are asking for hint. Uh, try finding a square. What is a square? You multiplied, No, you found B inverse and that one. Then? Okay, understood. That's what I want. If you use that one, correct. A shorter one, I can say. So like, can we start 49? So let us do 49. In 49, matrix B is given 1, 3, 1, 5. Right? A be a 2 by 2 matrix such that A into B inverse is equals to A inverse. One more thing is given. B, C, B inverse is equals to A. Let me ask you one thing. What we can say about the matrix C and A, how they are related? That much depth I don't want. Diagonalization, diagonalizable, that and all I don't want. Even I didn't remember that much. In state board they thought, somebody saying square matrix. Anything else you have other than square matrix? If you are there in last class, I think I thought something called similar matrices. Did we study something called similar matrices in last class? Yes, no, please. Did we studied similar matrices in last class or not? No, Yes. If we studied, then you should understand, no? C and A are similar matrices. Clear? Now, what they have given? They have given C power 4 plus alpha C square plus beta into identity is null matrix. What we need? We need 2 times of beta minus alpha. This can be solved using characteristic polynomial again. Notice that A into B inverse is equals to A inverse. Taking this equation, left multiply with A on both sides. A into A B inverse is equals to A into A inverse, that is identity of second order. A square into B inverse must be equals I2. So next, multiply, right side multiply with B. A inverse, B inverse into B is equals to matrix B. Next I can say A square is equals matrix B. I think dear Nishita, you are little louder. Can you reduce the volume? A square is equals to B I have. Clear? Understood? Right? Next, maybe I'm trying to use the second one, like how we can use the second one. Let us think quickly. uh, B C B inverse is equals to matrix A. Okay, like let me write that one. I need A square equals to B. I have maybe, let's say A square is equals to A into A. That A into A we can say B C B inverse into B C B inverse. Matrix multiplication is associative. I can write B C B inverse into B C into B inverse. Now I have identity in between. This is B C square B inverse is what I have. Anything, any doubt in this? This is A square. Now I can say it must be equals to B. B is equals B into C square into B inverse. Maybe right side multiply with B. B into B is equals B C square B inverse into B. We have identity. B square is equals to B into C square. Multiply with B inverse on left side. B inverse into B is equals B inverse into B into C square. So now C square is equals to B. Now trying to use this one, substituting in the given relation, it is C to the power 4 plus alpha into C square plus beta into identity is equals to 0. C square whole square, alpha into C square, beta into identity is 0. So now this is B square, alpha into B plus beta into identity must be 0. From characteristic polynomial, what I can write next to this, I can write here lambda square minus 6 into lambda. Okay, 5 minus 3 is 2 plus 2 must be equals to 0. So the matrix is B square minus 6 into B plus 2 into identity will be 0. Now we can say alpha is minus 6, beta is 2. So we need 2 times of beta minus alpha, so 2 into 2 minus of minus plus 6, 10 must be the answer. So let me know if any doubt is there in this part of this slide. Understood? No, beta is not minus. Beta is I think 4 2 I guess. Beta is 2, alpha is minus 6. Any doubt, Vishwanath? Let me go there, you can ask. In this, no doubt, right? Vignesh, Abhinav, Sujan. You are Sujan, you are Sujan. Uh, I want to ask you, but Sujan. Vedant, any doubt? Can I scroll up now? From girls, any doubts? So like Vishwanath, your thing is there in this one. Huh? Like c power 4 is there, c square whole square. Why? Because we have one relation, no? C square is b. So like now this will be b here, b square plus alpha into b plus beta into y. Now compare with the equation what we got from characteristic polynomial. Anything else? Clear? Anything else for anybody? So then like in page 33, which problem you want, please do let me know. I think maybe I will teach one in between 58 and 60. Most probably I'm not going to use that, what do you call, listing them and then finding the sum. I'll use something different, a binomial theorem concept. 60 and 58, one in between them. If you want anything, please let me know. I'll add that one. One or two is okay. Binomial theorem is like little trickier to explain and understand, so I should need some time. Slightly, can I scroll up? 50, okay, that we will add. Anything else? How we got alpha and beta? See, like I wrote here, no? For this matrix, I wrote characteristic polynomial. From Carey-Hamilton theorem, we can substitute. This is the characteristic polynomial. Now comparing this, for any one matrix, it will be only one characteristic polynomial, right? So compared with that, so alpha must be -6 and beta must be 2. Anything else? Thank you. Can we start? Maybe you only tell 58 or 60. 58, okay, thank you. Sir, you want? If you want, okay. Here also, I think we are deliberately bunking chemistry class on this. Just for not coming to maths class as well, sir. Only body is there. Brain is somewhere else.
Correct or not? Respond, man. What? What? Yes, sir. Huh?
Their friends are saying yes, so they are also saying yes. 24, sir.
Very, very good. Very good, sir. 24, 35. Attendance done.
I am not counting who is physically there in class, sir. I am counting like who is mentally also here.
No. Okay, sir.
Okay, sir. Tomorrow you are giving.
Tomorrow, I will take. Right? And someone who will wake up early. Daytime, who will wake up early? Who? Really, one of you. Make me to wake up, man.
No problem, sir. I will be here only.
Someone make me to wake up. Someone call me. Disturb me. You have my number. All of you call and disturb me. I will come to that. Today was exhausted. So yes, sir.
I don't know, sir.
Tomorrow we need to take week off and we will do on paper. It was coming Saturday or Sunday, you know, exam, right? So on
Saturday.
that, do on paper this time. I think one paper was posted in your channel already.
True, sir.
Paper.
Weekday, weekend. Sir.
Both paper. Day of the sort, day on paper.
Most of them don't know we post.
They are busy in schools till day.
Oh.
Tomorrow only they will see. Correct?
No, sir. They will
Yes,
see
sir, we are outside in school.
Friday only. They'll see. Sir.
Where is our Sunday? Yes. I guess we are doing okay, sir.
Okay. Thank you.
Yes, sir.
Okay. If anybody felt bad, sorry for that. For fun only, I said. I didn't mean actually. So like six. Which one you picked? I forgot. Short memory. 58. Okay. No. First this problem, then see, like, please don't make noise. To tell you are there here. Huh? You are saying something? Huh? Really? I asked in this space any doubt. Don't randomly take. No, I'll give hint maybe later. See, like most of you would have solved this problem in different way. This is what I do. I think I have explained this one to few of the students. That tall boy will be there, no? State board. I didn't know his name. Sorry, I didn't remember. Okay. So matrix A is a 2 by 2 matrix. Okay. A, B, C, D belongs to 0, 1, 2, 3, 4, and 5. Next. Okay. So we need to find A plus B plus C plus D is equals to P. P is a prime. It is lying in between 2 and 8. So then number of such matrices, like imagine we have a set of matrices in this form where A, B, C, D belongs to 1, 2, 3, 4, 5, and then it is satisfying the condition. Sum of all the elements must be P. P is a prime lying in between 2 and 8. See, like most of you would have solved in this way. Case 1, A plus B plus C plus D is equals to 3, manual counting, or maybe non-negative integral solutions. A plus B plus C plus D is equals to 5, and that one is equals to 7. That one is perfect. I'm not saying it is wrong. Maybe we have other method as well. That one is what I'm going to teach. If you remember, in binomial theorem or in permutation and combination, I think permutation and combination, you can also get the non-negative integral solution or positive integral solution in different way. Right? I am going to take the help of generating function. For generating function, we are saying f of x is equals A can be 0, A can be 1, A can be 2, 3, 4, 5. So this I am writing it with the help of x power 0. This means A is 0, A is 1, A is 2, A is 3, and A is 4, A is 5. It is either or, so I added. Now same thing for B, C, and D. So putting all 4 together, I should write power 4. You guys understood this one? This is generating function. A can be 0, can be 1, 2, 3, like that, it can be 5. So I wrote x power. Like that, for A we wrote B, C, D power 4 in this. Any doubt in this? Anybody? Now next. This will be equals to geometric progression. First term is 1, common ratio is x, 6 terms. Right? Maybe using the GP formula, it will be 1 into 1 minus x to the power 6 divided by 1 minus x whole power 4. Any doubt in this? No, this is generating function. Like the possible values of k. Let's say 2 is not there, you can remove x squared. A can be 0, so I wrote x power 0. A can be 1, A can be 2, 3, 4, 5. Like this for A. Like this for A, B, C, D in multiplication, you will get all. Clear? So now next, this becomes 1 minus x power 6 whole power 4 into 1 minus x whole power minus 4. Any doubt in this? Anybody? Any doubt in this? Anybody? Like first, listen right. In order to get sum of the elements is equals to 3, I will take coefficient of x cube. In order to get sum of the elements is equals to 5, I will get coefficient of x power 5 and x power 7 and so on. Clear? Any doubt in this? How to get the coefficient? You can expand this one directly, but this is little trickier. For that, let me recall this one. 1 minus x to the power minus n. This expansion I always write 1 plus nc1 into x. This is the starting thing. This much I'll remember. Next I will see a pattern. Add 1 above, add 1 below. This is n plus 1 c2 x square, n plus 2 c3 x cube, and so on. You have infinitely many solutions. This is under the assumption x is there in between minus 1 to plus. Clear? Right? In binomial theorem for negative integral index. Now, using that we are expanding, we get f of x is equals to. This one anyway you can directly do, that is 4c1, 4c naught minus 4c1 into x power 6 plus 4c2 into x power I think 12 and so on. I don't want more than this. If you multiply x power 12 with x, you are going to get x cube or x power 12 only. Some we don't want 12, so we are not taking it more than that. Now, next we are expanding here. This will be 1 plus 4c1 into x plus 5c2 into x square plus 6c3 into x cube, 7c4 into x power 4 and so on. Infinitely many terms I have. Now, notice that, right? If maybe for a plus b plus c plus d is equals to 0, sum of all the elements is equals to 0, we can say this is coefficient of x cube in f of x. Clear? How to get x cube coefficient? In this case, number of matrices will be, right? So how to get x cube? To get x cube, constant I can multiply with x cube. X power 6 if I multiply, 6 I am getting. So it is 6c3. I need some help. Anybody solved in different way? Can you tell me we have 6c3 in this one? If anybody solved this problem in some other way, can you guys tell me, are we have, okay, that is not required, I think. 4 plus 3, correct, 63 must be correct. How much is 63? 20, right? So, next, for a plus b plus c plus d is equals to 5. So, we will do coefficient of x to the power 5 in f of x. So, number of matrices. So, how to get coefficient of x power 5? Constant with x power 5, x power 6, we don't want. Constant, like you see the pattern, please. What you have below, you are adding 3 to that. It is 1 added 3 to that. 2 add 3 to that. 3 add 3. 4 add 3. Clear? So, like now, for x power 5, we are multiplying 4c naught into x power 5 coefficient must be C5 adding 3, 8C5. 8C5 will be 8 into 7, I guess. 3 factorial and 6 gone. 8 into 7 is 56. Clear? So now for A plus B plus C plus D is equals to 7. So this will be coefficient of x power 7 in f of x. Number of matrices will be. First, like notice that constant with x power 7. Perfect. 4c naught into 10c7. Next, x power 6 with x power 4. So it will be minus 4c1 into, I think I need x power 4, 7c4. Right, let me check. Perfect. So this will be 10, 9, 8, 6, 4 into 7, 6, 5, 5, 6. No, that you can see, no, x power 10 you will also get by multiplying this x power 6 with x power 4, right? So this will be equals to maybe 3 2s are 3 3s are 2 1s 2 4s. So 120 minus 35 into 4 is how much? Sorry? That, that much is not get. Somewhere mistake we did. If we multiply x power 6 with x power 4, 4c1 into 7c4. 7c4 is 7 factorial by 4 and 3.
So we should multiply x power 6 by x power 1, sir, to get x power 7.
Oh, yep, that is a mistake. Sorry, x power 6 with x power 1 I should do. Thank you for correcting me again. It must be 4c1 here into 4 minus 16. So it is 104. If we add 104, 56 and 20, I think we should get the answer. How much is that? Are we having the answer? Can you check from one side? Perfect. Then thank you. So last call. Any doubts in this? Anybody? Throughout the classroom? No doubts in this slide. Understood this problem? Please copy it. See, like maybe in 60th problem also you can apply this. There you are going starting from 3 going till 11. What I believe is instead of listing them, maybe in this way, you might get the answer. If I remember correctly, I thought this one to Vishwanath earlier. Correct? Huh? That time you understood. This time you understood. Generating function, that one called as. I think it was there in the module. I don't know whether you studied, they thought you learned. You know, permutation and combination are binomial theorem. Somewhere definitely will be there. Can I scroll up? Can I scroll up? So then Abhinav, you want 50? Okay. What you did there? Yeah, the intersection dear. Inverted U will. Intersection. probability did you study? Maybe that is intersection. Big, that means like summation we write, no? This is T1 intersection, T2 intersection, T3 going till T100. Now you can do a, okay. Can I scroll up? So that's it. Any doubts in here, I'll solve. Or else tomorrow class is there, we'll start. Next, A and B can be same in here. This is matrix A is in general. We do A square or something. We will get like if n is equals to 1, A power by finding A square. How do you find A square must be equals to identity? Use that relation. Use that like maybe next what you will get is see in T1 you have all such matrices but that A square is equals to identity. In T2 you have all such matrices but that A to the power 6 is equals to identity. Clear? In T2 can I write please take white see like I can say in T1 we can substitute n is equals to we have matrix A belongs to set n is equals to 1 A square must be equals to identity. In T2 A belongs to such that A to the power by B is equals to identity. 2 into 3 6 is equals to identity. What is my claim over here? Here, T2 is a subset of T1. Wait, if A square is identity, definitely A for 6 must be identity. Clear? So now you can show that T3 is also subset. Right? If all of them are subsets of T1, if A and B are two sets, B is a subset of T, right? Or A is a subset of T. A intersection B will be always the clear. Understood? T1. T1. Number of elements in T1 if we find that we are done. Yeah, understood. So any doubts? At least calls like yeah. We don't push the wings this side away. Is this okay? Any doubts in this part? Doubt? So like marking attendance, just let me know if you didn't punch downstairs so that we can mark present. Do we have Abhishek, Priyan are offline? Abhishek, Priyan are online, offline? Suray Aditya is there, yeah, please. They're on. Weekly. Ranjit SV, uh, Sarvesh Kumar P. Sri Darshan Ilan Kumar. Please stay quiet. So now tell me, somebody said they didn't punch the ID card downstairs. Sujit or Sujan? Sujan, okay, sorry. It is showing present here. Yes, dear. One moment, one moment. Attendance is 10. Which problem, dear? See, like, one, like, wants a small revision for limits. Maybe it might be, not sure, Monday or Tuesday I will start. You want? As of now, I don't have it. Monday, Tuesday, it might be one. 5:30 to 7, might be 7. Monday. So any doubts, anybody? Any doubts? So then I'm expecting everybody to score above 80 in matrices and determinants. I do check the results once it will be out. So like, don't bunk the exam, please. So all packed. Still 2 minutes is there. Wants to go home. Doubt. Which problem? What you did there? Fifth. It is orthogonal matrix. No. I think a square. Please stay silent. A square and all not necessary in this. It is like Q and B are similar matrices. I can say Q to the power 2021 must be equals B to the power 2021. They have given here matrix Q is equals to A transpose B into A. So square of this Q into Q, A transpose B A. I said quite. Why shouting like that? You want to go home? Go home. I didn't say anything. But like, don't shout like that. Matrix A is orthogonal in the problem. A into A transpose, you will get identity. In the same way, Q to the power 2021, A transpose, P to the power 2021, A. So now, left multiply with A on both sides. Done? So you can say P power 2021. Oh, they are asking inverse of this. So inverse na 2 by 2 you can easily do. Clear? We'll see. If you want to go home, you go home. I'm not stopping. Any doubts is there, you ask. Not. You don't want to go home, huh? I won't shout, Ray. Go home. That time I shouted because they are irritating from the beginning. Hey, go, Ray. I won't say anything. Go home. It's 8:30. You can go home. Ended only. Any doubts is there, I'll ask. I'll solve, or else I won't. I'll upload the notes. I won't target you. Don't worry. See, why I'm asking that guy is like he is capable of doing, but he's not doing. That's only I asked today. Tomorrow I won't. By the time I reach my home, I forgot these all things. You saw Ghazni movie, no? I am Ghazni. I'll forgot everything. Don't want to go home, huh? Then sleep here only. We'll see in the morning 8:30. Nobody going. If any doubts is there, you ask, or else you can go home. Oh. Hmm. That is only important. Did you studied in binomial theorem? See, like normally when you have a plus b plus c plus d is equals to some natural number, non-negative integral solutions or positive integral solution will apply. Correct? So like the actual derivation is from here only. So this is the derivation. If A, B, C are starting from 0, let's say it is starting from 2, you should start the generating function from 2. X square, x cube, x power 4 and so until what and all it is there. Clear? So here it is starting from 0. That is slightly trickier. We should not take here. In that case, like you don't have GP, no? If 2 is not there, there is no GP. That is trickier, difficult as well. Maybe we need to think some other way. Clear? Anything else? This is only important. It is in from binomial theorem. We can take like this derivation and you can prove non-negative integral solution and positive integral solution as well. How many variables that will be coming in power? What and all we can take in the variable that will be going till here. Let's say you have x1, x2, x3 going xr going till n, right? So in that case, we will write it is starting from x0 and then x1. It will go soon, like whatever you want, you can take, but the power is number of variables. In this, they have clearly mentioned it is 5. If they didn't mention, you can put dot dot. Anyway, it is GP, finite or infinite GP. Anything else? To be honest, you don't have enough time to do 12th only. What chapters you have backlog? Huh? Only one chapter. That is important, I think. You can go home. I won't say anything. binomial expansion, one problem might be coming. Maybe I can tell you. I'm not 100%. I won't say this, but like most of the times, problem might be on uh, independent term, that is of general term, or it might be on finding remainder. So maybe if you are good in these two, I can say you can solve the problems. Revise once. Do last 2 years or 3 years PYQs as of for revision. Maybe one more year. Anything else? Your handwriting is nice. Give your notebooks once you are leaving this course. Oh, thank you. You are still in the online. Any doubts, online students?
No, sir.
Okay, you can leave now. But Vishwanath and Vignesh, some discussion.
you.